So like I told you, I was just going to do this with poor audio and answer it quickly just so you can remember the steps. A scientist claims that the pneumonia causes weight loss in mice, and he takes paired data essentially here because this is the same mouse, mouse number 1, mouse number 2, 3, 4, 5, 6. It's just the mouse before the infection and then the mouse after the infection. And that's how you know it's paired data, so that's kind of significant. And let's answer the question. So, and I'm going to use StatCrunch to help. So identify the claim and state them symbolically. He claims that pneumonia is causing weight loss. Okay, so pneumonia causes weight loss is B. No big deal there. How about stating symbolically? So what we're saying is that the average difference is going to be greater than 0. It's going to be some sort of positive value. That's what we mean when we take a claim like this. We're saying the average difference has got to be something significant. I'm using a word here that has actual meaning in another place, so don't take that word. That is just going to be positive, okay? There's going to be some weight loss. So the inverse of that is that you have less than or equal to 0 weight loss, difference, average difference, which makes this one right here the alternative statement, where it carries the equality, and this one right here, the alternative statement. Did I just say alternative on the last one? I don't even know. Good thing you're the only one watching this. Okay, so this one's the alternative, where it has the differing statement. So remember, that would also tell us that we have a single tail. It's going to be a right tail test. And in our mind, we're visualizing a curve. It's going to be a t-distribution because we don't have population parameters. We have sample statistics. We're going to be considering the rejection region over here. It's going to be at a 5% level of significance. If we fall in the rejection region, then we will reject the null, and so on, so on, so on. Okay, here's how I run the test then. Let me grab the answer, by the way, for that part. Oh, sorry, not that. It's got to have equality. Yeah, I guess so that. Okay, so, oh, and this one you also already know how to do. You look up on the table. So here we look for degrees of freedom of 5 because there were 6 mice in the sample. And we come across looking for area in one tail. That's the top with 5% in one tail. So 2.015. That's probably the best way to do that. And we're on the right side. So far the technology really hasn't stepped into play yet. Okay, now for the rest of it, I go StatCrunch. And then I choose stat t statistics because we're using t-distribution, paired data, with the first one being the weight of the mouse before infection, next one being the weight of the mouse after infection, and you definitely want to click this box to save the differences. It's going to help you with the part that I'm doing next. Then you got your null and your alternative. This is saying that there's some sort of weight loss. hold on to this. If you want, you can actually just write this down because it's going to come back to us in a few steps later. Yeah, I can. But right now, I'm going to go to the list where the differences are. I'm going to use stat summary statistics on that column of differences. You don't really need all of this stuff, but you need the mean and the standard deviation. So if you want, you can uncheck some of these. Yeah, I'll just do it like this. I'll click on mean and standard deviation, or you can hold down. So you can like click on mean and hold down to standard deviation. Just get all three of them in there. We don't need variance. Yeah. So the mean is 0.5. It found all their differences for the 6 mice and averaged them. Unless I didn't. .05, 5/100ths. And the standard deviation from the sample, 122. Okay, and then the standardized test statistic. If you didn't copy and paste it or write it down, it's still in your StatCrunch for the open session. Click on StatCrunch, go to session results, go to the paired T test that you did, and it will have it there. T statistics is a 1. Or if you had written it down like I did, you've got it right here. What that means is that we've got our standardized test statistic falling. Oh, actually, give me just a moment here. I didn't ever write down what this turned out to be. So our critical t-score turned out to be 2.015. And we actually have our test statistic of a 1 falling below that, which means that the p-value is going to be bigger. In other words, it didn't fall in the rejection region. In other words, we're not going to reject. So this one turned out differently. So decide what to do. Well, if this is a 1, and we're only rejecting when we're greater than 2.015, then we won't reject. So fail to reject. Which means then you got to think of your whole list. And since I know you like this one, I'll use this. Does the original claim contain the condition of equality? For us, no. He was claiming that there was going to be weight loss, strictly. Did we reject? No, we failed to reject. So there is not sufficient sample evidence to support the claim that pneumonia causes weight loss. There is not sufficient evidence to support the claim that pneumonia causes weight loss. I know you know how to do this. I just wanted to, again, show you this part. Okay, so you do stat, t-stat, paired, choose your first column, choose your second column, save the differences. I won't bother with that because I already did. Once you have the differences, you do stat, summary stat, column, and choose it. And you might as well just hit compute and do it all. If you want to go back to any of those results, you do them right here. So there's the summary stats that I had. And here is the paired data, t statistic.